X server can issue dialogues.
Oh,
Say it again, Mihai.
So that an X agent can add dialogues to the running session.
Yes, exactly.
Because we already have another way. Yeah.
Yeah. And it's a nice thing to have to because so you won't suspend immediately, but you will get a dialogue and it asks you, do you want to suspend? And then you say yes, or you say no, and then you sort of get out of the suspension thing.
Or it shows you when you, for example, switch on auto grab or switch it off.
Yeah.
It confirms your switch.
Okay, we are back again. Our stream is running. Uli, you can continue if you want.
Shouldn't this NX dialog not be like a lib indicator thingy for the taskbar maybe?
Maybe, but that's a completely other can of worms.
Okay.
We also have a ticket about redesigning that whole dialogue stuff. That's quite old, and Mike has added some ideas how to implement that.
Well, the question is, I don't want to have a pop-up every time, for instance, you enable or disable autograb. That would be killing user flow,
Yeah, okay, I get that.
Yeah. I mean,
maybe we
because
should make that configurable.
Yeah, probably. Well, the thing is, if you have just a notification in the notification tray area that is shown by any desktop really, maybe not stuff like OpenBox or Fluxbox, but
yeah, but
most desktops can do that.
That could be really done, so that some actions actually end up in a dialogue where you have to decide something, and others are just lib notify notifications.
Right.
Yeah. That would be.
I guess they have wrappers for that kind of stuff, so we don't. Yeah. We can do that via NX dialog. We just probably have to extend NX dialog to have notions of different types, like interactive types and notification type messages or something like that.
Okay,
he already has.
Going back to Uli's talk now. He has about 10 minutes left now.
One thing I have not on the slides is also related to NX dialog, and just comes to my mind. I have changed the code that it now also can display the currently configured keystrokes when you show certain messages, because these keystrokes were hard-coded in the text, but you could change them by the config file and it was not reflected in that text. That is now working. I was already talking about screen saving being possible within the session now when you use the timeout option. Now, I've documented within the code the meaning of some internal atoms that was not clear, and they had some misleading names also. So I researched what they are used for and documented that. Then I tried to find all code we derived from Xorg and mark all changes we did. This was not done before, and so it was difficult to backport any fixes that came from Xorg, and this is easier now. Then a lot of code depended on fixed length strings that were allocated at program start. I removed most of them and used some string duplication or allocation code, so it's working better now. Because I'm using a self-compiled version of NX at my work, where I sometimes test fixes, I started to become confused what version I'm currently using. So I added codes for custom version string that you can set during compilation. And I enabled UTF-8 for clipboard code that was mysteriously missing all the time. We had some UTF code in the code, but it was not advertised programs asking, do you support UTF-8?
That's actually something that might cause a clipboard bug.
It might cause or fix a clipboard, because previously
previously, like not announcing UTF-8 support. Like you have a string with some Unicode character in it, and you copy and paste it from one machine to the other. I could imagine that this gets mangled in some weird way, like before you applied your fix.
No, and well, the existing code had some logic by Dimbor that always sent UTF-8 content, but it did not announce that it is supporting UTF-8 code. So what you get now is the same you got before.
Okay.
It's just announced cleaner. We can talk that at length tomorrow. Okay?
Yes, please go on.
Okay. Now an ex-colleague of mine was working on updating the continuous integration stuff. Any commit we do will be compiled in Travis, and it is also now using GCC 10, and it also is using CLang, and it even supports PVS Studio, but only for those people that get their personal free key from them and adds them to his Travis account. But it's working nice, and PVS Studio is really a software that's great. We also had some new bugs, of course. That one I already had last year, but I didn't work on that one. There are some problems when cloning keyboards in shadowed sessions, and I still have not come around to look deeper into them. And then a lot of bugs came up from people using the Mutter window manager. It seems like this one is doing really weird stuff. And I was able to fix a bit of that, but it is not fixed as a whole. I must work more on that one. And the last one is a quite new one. It appears that the clipboard is slowing down when you are using an NX session, even the local clipboard. Most notably, when you have an sorry.
I believe I ran into that issue as well.
Ah, okay.
So we might be able to trace that down tomorrow.
I think it's a follow-up of clipboard stuff working better. It's when you have an NX session running and you have you're locally using Chrome, you can see that problem if you try to copy the URL bar. It takes sometimes several seconds before you even get the menu for where you can select copy.
Yes, that's exactly what I ran into just a different browser.
Okay, maybe we can look at that. Now, I have stuff lying around on my local disk that is not finished, and I have listed some of them. The mentioned colleague that also did the continuous integration worked with me on replacing all of the iMake stuff by Automake. That code is ready for a year now, but it must be updated for the current version, and somebody should take a look at it before we implement that. Then I think I started that 2 years ago to
Uli, I volunteer for that.
Okay.
Yeah.
I think you have the ticket already.
But not the code.
Yeah, you have everything in GitHub.
Shit.
then I want to lift the code to support the whole feature set of Xorg 1.4.2. That's mostly done. I just need to lift it up to the latest NX code. Once we have that, we can easily update to 1.5.0 feature set, and from then on, it should be relatively easy to do the next steps and finally reach 1.20 eventually. That is a dream of me. Then what I also discovered is when you using nested sessions in rootless mode. So when you do a rootless session where you just get an X term or something and start another one from there to another destination, you cannot use the first session anymore, the local session anymore, because there's some screen grabbing stuff involved. I improved that, but it's still not working perfectly. Then there are a lot of variables in the code that are actually booleans, but aren't used as booleans. Well, C doesn't support booleans, but at least the code has some macros for defining booleans, and you can simplify comparisons by simply checking if it's true or false, which cleans up the code again.
We've had a few technical glitches early on, so I decided to give you a few extra minutes, but you should finish within the next 5 minutes or so, if that's
I think
possible.
I have this in the next slide, and then I'm done. So I have some code that makes even more use of the Xorg timers I used for the timeout stuff and the splash screen, and that will enable us to drop a huge part of the code from Xorg that had to be derived and changed. Then a colleague of mine is also using NX. Well, before Corona, now he's not using it at the moment, and he constantly came to his office desktop in the morning and tried to connect to his remote session, and it did not work anymore. The reconnect never was possible, and it turned out that this is connected to the sleep option we offer. If you have a session that is doing a lot of graphic stuff, then all those graphic operations pile up, and the code never reaches the point where it can detect that someone wants to reconnect to the session. The fix we found is connect with GDB and patch some variables, and then you can reconnect. I've debugged that, and I have some code that will probably make that issue vanish, but it needs some polishing. I have some more fixes for the Matter window manager stuff I mentioned before, and I also have code for the keystroke to reset the clipboard. But here I'm currently a bit unsure what what state the clipboard should have after that keystroke. But it's not a big thing. Well, and then this is the last slide. I wanted to mention some stuff that came up during the last year. Around Sylvester, Dimbor. I mentioned Dimbor a couple of times in this presentation. Dimbor is a programmer from Russia that added some code in the past to NX, and from time to time he suddenly appears and contributes stuff. And he's also roughly connected to Ethersoft, who's also offering an NX-based product in Russia. Well, he vanished. He appeared around Sylvester and showed me his own version of OpenNX and of FreeNX server. So what he did is he has an OpenNX version that is running on current distribution. You might remember OpenNX was a free alternative to the NoMachine NX client that could be used to connect to the FreeNX server or to the the NoMachine server. Well, he has a current version with some enhancement, and he also has a current version of the FreeNX server with some enhancements. FreeNX was abandoned years ago, it seems, but now we have a current version, and under those two URLs you can get that and drop X2Go as a whole if you want to. You can still use NX, the version from Arctica.
I have, in fact, thought about also packaging that for Debian. Oh, you might not want to hear that, but it's just as a study, as a case study, and also to have a counterpart for Remina NX plugin to test the NX plugin against.
Yeah, I think the free NX server here can simply be used with the Remina, right?
Yeah, it should. The only thing is that in NX you had private and public DSA keys, SSH DSA keys that were shipped bundled with the software. For the initial handshake, you had some SSHing into the server, and that was handled by package-wise deployed SSH keys, private keys and public keys, and they are still DSA, the old ones that have been used. And DSA keys are disabled in recent SSH versions. So yeah, one should talk Dimber into generating an RSA or whatever key, because the concept cannot be dropped of shipping keys, but they should be sort of updated to some recent algo.
Yeah, that's a GitHub repo, so you can simply open an issue.
Yeah. Thanks for the links. I haven't known those.
And around that time, I tried to use that, and I also wanted to find out what special stuff the original low machine NX client was doing, because there are several parts in the NX, several locations in the NX code that well, they do strange stuff, and I suspect that most of that stuff is connected to communicating to the original NX client binary, and I wanted to find out what this client was doing. So I wanted to connect with that client to the new free NX server, and it didn't work because the NX client is quite old and doesn't work on current distributions. And open an issue there, and someone provided a preload binary that fixes those issues and makes the really old no machine NX client work on current systems. Then I greatly enhanced the workaround description on the X2Go wiki, because more and more people came up with GLX problems. And I think we should even go a step farther and provide some little wrapper and a compiled GLX xlib, so that people can simply run their GLX, their OpenGL applications with that wrapper and don't have to go through that lengthy manual workaround. What do you think of that?
Is that a packaging thing only, or upstream development in some sort of way?
It's well, you should add the compilation of that workaround library in the X2Go build process and add it to the X2Go packages.
Yeah, but is it something that is required when NX agent is built, or is it something just an LD
at runtime?
At the runtime.
It's required at runtime.
Okay, so then it's okay.
The idea is that people start their X2Go session, and then they want to use an OpenGL application that's not running out of the box with X2Go.
Yeah.
They can run a little starter, for example, X2Go GLX, and then their program.
Okay.
And it will set up the environment and start the program.
That sounds nice. Okay.
I have mocked my idea on that side.
Okay. I mentally made a note.
Okay. The last two things, well, I had some motivation problems the last months because we started to have really long review cycles. Sometimes I had to wait for months before anyone took a look at my pull requests.
I'm sorry for that.
This is not even demotivating. It's also creating problems when you try to depend on a feature you already had a pull request, but it's not upstream, and develop the next code. So I really hope we can speed up that again.
Okay. So as I am, Yannick, you have done reviews as well.
Yeah.
but I've been the main reviewer, the one who did that, and I created these long cycles. So I'm sorry for that. It's just probably, yeah, I could have excuses, but I don't. Be nasty with me and ping me and ping me and ping me. Get on my nerves. That's the only thing that really helps. So that if I get that ping in a free minute, I'll do the PR review.
Okay, everybody has heard that. I'm allowed
Yes.
to nag Mike.
Use all the channels, text messages, email. Yeah.
Okay, I will.
Yeah, please. And then I'll be happy to. It's just
folks, we really need to speed up so Chris gets his chance.
Yeah.
Okay, last sentence. That is also interesting. Most people say, "Oh, I don't know what to do in my free time that I got through Corona, COVID-19." That was not the case for me. I didn't have more, but a lot less time. I'm not really sure how that came, but I didn't come around to do anything I wanted to do. I don't know. Was it the same for you?
No. I was busier. This is Chris.
I guess we all were. And there's this thing called Zoom fatigue.
Was Zoom fatigue?
Yeah, like when you spend too much time in Zoom meetings or in Jitsi meetings, if you're an open source person, then you just feel tired in the evening, exhausted.
This could be, yeah.
Well, and I had
a lot more telephone conferences.
Yeah, and I had a lot of people who actually needed IT support. So schools needing e-learning management systems, stuff like that. So I was actually working quite a lot and had loads of paid customer projects that I didn't want to disappoint. So less free time for free development.
Okay, so I'm not alone in that. That was my presentation. Thank you.
Okay, so we're already past the next break. So Chris, are you comfortable with starting now?
Yeah, sure.
Okay, then let me just point out to Vadim that his talk will now move to the 2025 slot, if I'm not confused. Let me check again. Yes, Vadim, sorry, we can't do it any sooner. 2025 for yours. I hope that's okay for you. And one comment in the chat. Okay, that was Vadim giving his okay. So Chris, let's roll.
Okay, let me. Okay, is everything okay there? Can everyone see that?
Yep.
Okay, so firstly, thanks for inviting me to this. It's interesting to meet everybody and hear what's going on behind the scenes with X2Go. And I guess I'm gonna just talk about or kind of tell a story, looking at from the other side. So kind of as a user of X2Go, but how I came across X2Go and what we use it for and what it's turned into for us. So more generally, then we're talking about I work in scientific computing, and specifically, it's something called computational fluid dynamics. I've been involved with an open source software called OpenFoam for nearly 25 years. It's a really big project. In this area, there's two in particular, really large companies with commercial software where they're charging license fees. It starts at sort of 20,000, whatever currency you like, per year for a single user. And probably the second biggest of those two was sold recently for $1 billion or nearly $1 billion. In fact, it's Siemens who owns it now. But we're the open source alternative. We've probably got as many users as certainly the last company I just mentioned, the second of those two. And so we're have quite a big responsibility now for this software. It's a whole chunk of C++. The software runs in parallel, so you can run simulations on clusters and supercomputers and so on. And one of the major bits of third-party software we rely on is ParaView, which is for visualization of the results. But anyway, the rest of it's just our stuff. So just give you an idea what CFD is like. You want to simulate some fluid flow. So in the case of the air going across a car body, you generate what we call a mesh, which is a kind of breaking up the flow domain into a bunch of cells, and you can see that there on the screen. In order to, you can have cells of different size. You certainly need small enough ones to resolve the details of objects at the boundary of the fluid. So around the car there, you've got some small cells. If you look a bit closer, you can see the sort of size you could be dealing with, which means that you're going to end up with quite a large number of cells. And you solve equations for fluid flow, forces, heat, thermodynamics, chemistry even. You can have discrete particles in there. So there's a whole lot of functionality that we have. And for that case, you generate a flow solution. These are streamlines of the air kind of relative to the car. You get typical thing is recirculation in the wake. That'll determine to a large extent the drag force on the car. So people are going to use this for predictions of drag and lift on a car. And some of the big automotive companies use it. So VW Group in Germany and elsewhere, they're using the software. There's other applications I can show you. So from marine engineering, this is a propeller, and you want to use this to calculate the thrust, and there's a kind of balance between the rotational speed of the propeller and the flow speed of the boat. You're looking at there the speed of the water being driven away from the propeller. Red's the high values, blue's the low values. You get these little structures where the flow sort of goes around the tips of the blades, and in the bottom diagram you can sort of visualize those as these sort of little tubes. So that's one application in one bit of engineering. We do a lot of work with chemical engineering, process engineering, particularly in Germany. So this is a stirred tank where you've got a reaction going between a liquid in the tank, and then you blow gas through the tank, and you stir it up to control the bubble sizes, and that'll control the speed of your reaction. So here's a simulation. Obviously the blue bits there on the left are the sort of bubbles that are being generated. The baffles are the shaft spinning. The baffles are mixing things up, and chemical engineers will run simulations to try and optimize something like this. And then civil engineering, in the bottom, probably better in the bottom, you can see this very large weir. It's what we call a spillway on the edge of a dam. It's actually a huge dam in Australia. I can't remember. I think that the length from left to right is about 1.5 kilometers. I think the height of the spillway is 35 meters, so something like that. And if the reservoir overflows and the water flows over the spillway, then you can see it traveling down the spillway and off to the right. But what you end up with in this kind of problem is something called a hydraulic jump. It's a sort of strange phenomena where you've got quite thin layer of fluid down the front of the spillway, but you get a jump in height in the fluid, and then that causes sort of a lot of air to get entrained, so you get this foamy sort of mass of air and water, and that tends to churn, and it tends to erode the spillway, which can be very dangerous. And academics use it. This stuff. This is a sort of fundamental problem where you've got a sort of fluid in a domain there. On the bottom, the surface is very slightly warmer than the top, so the air at the bottom is heated up, and it wants to rise. But how's some of the air going to rise, hit the top, and fall down? Well, these sort of cell-like structures develop because you've got a bit of air rising up, and then it'll travel along the top and fall down. And because the air's going up in this section, the next cell runs in the clockwise direction. So you get this alternating clockwise, anti-clockwise flow. You can see you could actually see this effect when you're cooking a kind of curry-like sauce in a pan. If you see little sort of cell-like structures on the top surface, it's to do with this. Now,
Chris, the halfway mark of your talk.
Yeah, okay. So, how does X2Go come into this? So we're not academics. We're all working. We're a company dedicated to providing this bit of software. So we need to find some way of earning money. Traditionally, these are the three things we've done. So provide services around the software to earn money, development of the software, support of users of the software, and training. And in the training side of things, we've been doing a lot of this for over 10 years now. I've been the main trainer, traveling around the world, delivering training in training centers and on site. I've done over 500 days worth, 2,500 people. Some point about 4 or 5 years ago, we decided or thought we needed to be able to deliver training online. And so we put a kind of package of tools together to enable us to do that. We had video conferencing. Originally, we just used Hangouts, which was reasonably effective. We've sort of turned to Zoom a couple of years ago. For the participants, we wanted to have pre-configured machines. So we got those set up on the cloud using Amazon Web Services. And then we stuck the X2Go server on those remote machines so that the participants could connect with the remote desktop. So that was our choice of remote desktop from day one. I guess, it's worth asking why. So why does a user choose X2Go? Because for me, it's the standout option for something like this. Well, one, we deal with open source software, so generally we want to go down open source routes. A big thing for us was the multi-platform client support, so Linux, Windows, Mac OS. We knew people were going to be attending this training from using those kinds of machines, and I'm not sure there was anything that could offer that. The fact it was packaged for Ubuntu was great for us because our preferred platform for the remote machines is Ubuntu, so we could just unpack the server software on there, and also it's convenient on the client side as well. We've run courses around the world where the remote machines are quite a distance from the customer. So let's say someone in Japan running on AWS in Singapore, and no one's ever complained about the speed of the system. Personally, I've had hundreds of people through the training, and I would say it's been really reliable. There's maybe a couple of things that have cropped up from time to time, but I think maybe it's that we don't use all the features because we don't need them, but the core functionality is really great. And also screen sharing was important because we needed the instructor to be able to go and to log onto the machine, to connect to the machine and help the user out. We can be running courses like this, so participants attending from 8 participants from those locations there. We run the remote machines reasonably locally, but they're not always that close. Once we got all that together for training, we thought this is really useful. The combination of cloud plus X2Go, can we make that generally available to people? And very quickly we found we put it on the so-called marketplace of AWS. It looks like this, the remote desktop, so we can do everything we need. We've got the ParaView visualization, terminal, the Mate or Mate desktop. We're the latest. Currently, we're running 1804, but we're probably going to move to 2004. So it's now a product on the marketplace. We charge 2 cents a core hour on the software. The hardware cost is roughly 10 cents, but people often do CFD using the unused capacity with spot pricing. So still the software is cheaper than the hardware cost. So people are quite happy just to pay for this convenient pre-configured system. An X2Go server is an integral part of that system. We created a command line interface for deployment, which has been really good. What I found was that using, I can also incorporate the desktop for that, and so the X2Go client. But I found using the Pi-Hoker client was most useful for that. It's got a couple of features that were very advantageous. And yeah, the system's great. On the cloud, you can create clusters now with pretty good scaling and do some really good CFD. So cloud's added to our list of things. We, at the same time, we sort of identified maintenance as a separate sort of thing that we were doing. I'll talk about more of that in a minute. All these things are quite tightly bound together, so we have a closely knit team that works across all those areas. One thing I will say is that if the services are on the left and the sort of some key activities relating to that are down the middle, like redesign, like Uli was saying, that a lot of work I think he's been doing, repairing new code, etc. I think these activities relate to those services, and what comes out is a much better code. So on the right, I'm really talking about the code qualities that come out of those activities. We sort of highlight these things as the 5 qualities we want from our CFD software, and if we work on those, then it would make a much better code. To the extent that I think developing scientific software without a services business behind it, just will never produce the same level of quality that we've achieved with OpenFOAM. So it's really the services that lead to the activities that lead to the quality. Some of those things, historically, we didn't feel anyone was paying for them, and we knew how much they cost. And I chatted to a guy called Mike Woster. He's the Chief Revenue Officer, Linux Foundation. And he gave me an hour of his time one day and just said on the phone and said, basically, tell your customers that this cost is there, this work has to be done, and get them to pay for it. And he really insisted, he really pushed me. And so we started to do that. And after about a year, we launched a campaign to get the cost of that work funded. And there's the cost. And first year, we sort of reached that target you see at the bottom. Last year, we were there. This year, we're there. So we're steadily creeping up to have the maintenance of the code fully funded. My last word is then that because I'm in that situation with managing an open source project, I appreciate the situation of all open source projects, and I can imagine that X2Go is in the same situation. So, we've put a bit of money into the X2Go project, but our view on this is that we're committed to that. So basically, out of the money we make out of the cloud,
and we are very grateful for that.
yeah. Well, out of the money that we get from the cloud, we are going to consistently hand over a fixed percentage of that profit. So profit we make from the cloud product, a fixed percentage will always get transferred to X2Go. It's not like an act of sort of altruism that we do this. It's because you're a critical element of this product we have, and so we want you to be successful, and so whatever we can afford to give you, we are going to do. That's it really. But Stefan knows that I've interacted with Stefan about sponsoring the event, and then this year we sort of moved that funds to elsewhere. My view is that it's really hands off. You obviously know how to produce a good product, so you spend the money however you want. It really doesn't matter to us at all. So we will continue to do that. To fund you, and just to say that the usage of that cloud product is increasing, so the funding should increase each year.
That is really good to know. And I think there was only 1 year in the past where your funding was not enough to fund the macOS cloud host that we use for the macOS client builds. Like from the beginning when you started up until now, there's just 1 year where your funding was below the required amount. So that's really cool.
Well, I think, yeah, and on that, I just think, Stefan, we might just, I know at different times in the year we kind of we connect about the funding, but we probably should just sort of formalize it and just kind of go, okay, on this date, like every year we'll get in touch and I'll let you know what the situation is. But yes, I want to thank you all really sincerely. Everyone in our company CFD Direct is hugely grateful for what you've done, and we're trying to express that gratitude by funding you in some way, and we'll push it. We'll do whatever we can to make sure that you have some funds to work on the code.
Thank you very much. So we're almost into the time slot for Vadim's talk. We have like 3 minutes if anyone has questions for you. So please raise your hand, make yourself heard. Uli would like to speak. Yes, Uli, please go on.
Thanks for that interesting presentation. I would like to know if you're using RDMA within Amazon Cloud for that distributed workloads.
No, is that? I'm not up on all the technical stuff. Is that to do with the authentication or?
No. RDMA means remote direct memory access using InfiniBand interconnects, for example.
No. So for the CFD, for the parallelization on CFD, AWS doesn't have InfiniBand. It has its own network connection now. So there's sort of its own sort of protocol. There's OpenMPI has support for it, I think now. So if we just use a recent version of OpenMPI, we can use this thing. They call it a network connector. So they've got their own network connector to improve or reduce the latency for the communication on when you're running a cluster. So this is a CFD issue. I'm not sure if your question was about X2Go or was about the application we're talking about.
Oh no, it's about HPC compute.
Yeah. Okay.
Stuff, because that's what our customers are doing.
Right. Okay.
The company I work in.
Okay.
And RDMA is key in performance, so that I was just wanted to know if viewers?
Well, yeah, just a quick answer then. That yeah, AWS introduced or did a lot of work about a year or two ago on particularly on reducing latency for parallel communication across clusters, and it had a very good effect that we were getting linear scaling at sort of 500 and 1,000 cores when we hadn't been before. So I think suddenly they very suddenly were able to sell their platform as a system that you could in which you could cluster instances, and it was worth your while doing so. It was good.
Okay.
It was a good platform.
Okay. My second question is short. You mentioned two competitors commercially. The one is Star CCM, of course, and the other one is Ansys.
Yes, Ansys. Yeah.
Okay. Oh, thank you.
Yeah.
All right, so it's time for Vadim's talk, finally. Vadim, please unmute yourself, turn your camera on, turn your screen sharing on. Let's go.
Hello. Okay.
Vadim, I'm sorry, I have to leave right now. I'll catch up on YouTube.
Okay.
Thanks a lot, everyone. Goodbye.
See ya.
See ya.
Bye, Mike.
Bye.
My camera doesn't want to work. It says error obtaining camera permission. What the hell? It worked right just before.
Okay, then let's try it without the camera. Just do the screen sharing then.
Yeah, I suppose that's kind of a pain, but that's strange.
We can try later on for the Q&A to get you full screen with the camera again.
Okay. All right.
Sorry, quickly, Stefan. I think I need to go. I've just had a text from my wife saying that she's just got dinner for me. I'll catch up on YouTube and at a later date.
Okie doke.
Yeah.
Then enjoy your dinner, enjoy your evening.
Thank you, everyone.
And talk to you soon. Bye.
Okay.
Bye now.
See ya. Okay, well, let's get started then. Is this working, right?
Not yet, no. We don't see any screen sharing yet.
Okay, sharing. Okay, there we go.
No, okay.
Okay, so I'm Vadim. I work for Kindle, a consulting company, and I work on QVD, which is a desktop virtualization product. So this talk is going to be about how we implemented audio compression. And now, first, a little introduction, just so that everyone is clear on what's going on here. Kindle Group is an international consulting company. We specialize in Linux, and we do many things, including software development, support, and IT training. And we also have our own product, which is QVD. It's open source and available under the GPL3 license. QVD is a desktop virtualization system. It's focused on high-density deployments. Right. So, just the basics of what QVD is about. We provide virtual desktops for our users. This can be for things like testing or providing a highly specific unrestricted environment to the employees of a company, or it can be used to provide a perfectly normal remote desktop. We support KVM and LXC containers. Basically, in our product, what we try to do is to maximize the number of desktops that fit into a server, so we definitely prefer LXC. And we also try to work with low-end connections, which is where things like bandwidth usage become important. But on the other hand, we also want to be as functional as possible. So if somebody needs sound, or for instance, we want to be able to provide it. All right, we don't use X2Go. What we actually use is the NX libraries to provide the desktop environment, and we build our product on top of that. And yeah, okay. And as I mentioned, we right. And in different types of deployments. We may be providing desktops that are only temporary. And all the data is lost after it shuts down, so that every time, for instance, an employee logs in the morning, they get an entirely fresh setup. So this also influences a little bit our motivation for this, because we want to avoid anything that could interfere with the host machine. Right. So what happened here? Give me a second. It's out of order. Okay. Audio. A quick introduction to how audio works in NX. NX agent listens on the media port. The connection is forwarded to the remote site, that's to the client side, and it just connects to the Pulse audio server running over there. And the virtual machine has the Pulse server environment variable pointing to the port. So that's pretty simple. That's how it works in the default implementation. So the upsides of the setup, it's simple, and really nothing much besides that, because it has a whole lot of disadvantages that we found. So first of all, bandwidth usage is enormous. There's no encoding of any kind. So if we're speaking about sending normal quality audio, that's 1.4 megabits per second. That's not very good. An additional problem with this is that audio uses one connection per application. So if by some chance you have more than one thing going on at once, like for instance a YouTube video and just some system sounds, well, that's going to be 1.4 megabits per application. Another issue with that is that applications lose their audio connection when the user disconnects, because it's the connection goes through the NX channel, and once the session is suspended, and that channel disappears. So every application suddenly is disconnected from the audio server. Also, the way this works actually provides a little bit too much access to the host's Pulse audio server, and we don't quite like that, because, well, it does introduce the possibility that something might interfere in some undesirable way with the audio system of the host. So that definitely should be avoided, especially things like changing settings and loading modules. And finally, there's the issue of that audio traffic competes with other NX data. The NX system goes through just one TCP connection and has an internal system that interleaves the different channels between them, which means that if something is keeping the system very busy, it can actually downgrade the performance of the desktop. So not only do you have bad sounding audio, you're running into bandwidth problems, but you also are going to run into the desktop itself and starting to malfunction. So that's not very good, and that's definitely something we wanted to fix. So we've come up with a solution for this. First, we run a Pulse audio server inside the virtual machine or container. This solves already two problems. First of all, that the audio server doesn't disappear, because there's always an audio server running, and that means, and Pulse audio is just nicely accepts connections, even if it can't play anything anywhere. So pretty much nothing notices that this session is suspended and that there is no audio available. Also, an extra benefit of this is that Pulse Audio provides mixing. So just having a local Pulse Audio server means that we just get one audio stream on the output. So even without any compression at all, we're already saving something if anytime there's more than one thing going on at the same time. Now, on top of this, we implement Opus compression for Pulse Audio. This has many advantages. First, of course, it's dramatically lower bandwidth usage. The normal bandwidth use for uncompressed audio is 1.4 megabits, and for Opus we can easily compress it down to 64K or even much lower. Opus is also a very modern, flexible codec, which gets anywhere from CD quality audio to very low bitrate. That's
one question, if I may. You said 64 kilobits. That's for the audio alone, or the complete data transfer, like the NX signals as well?
No, we're talking about audio only here.
Okay, so that's on. Okay.
Yeah, NX just consumes a variable amount of bandwidth depending on what you're doing on and what's on your screen. This is 64 kilobits as a kind of suggested value. You can change it to anything the codec supports, which is, I think, from 512K down to something like 4K maybe. Okay. So yeah, Opus is a very modern codec. It's the successor to the Vorbis codec, which was already a worthy successor to MP3. So we're working with very new and very good technology here, and it's used, for instance, in Jitsi and Discord, among other things. Another benefit of using this codec is that it's actually adjustable in real time. So there exist some interesting possibilities that we may be able to use in the future. So this improves desktop performance by a lot, because since we're interleaving audio with other streams like the X11 compressed data inside the same socket, well, performance might be affected. It's actually just compressing audio improves it by quite a lot. Additionally, it's a variable bitrate codec, so if there's silence going on, it takes almost nothing on no bandwidth at all. And yeah, it can be tuned for the desired quality of bandwidth. So if you want to listen to very high quality audio, you can. And if you just want to hear the occasional notification, you can tune it down to something very small and that also works.
Have you considered doing this dynamically, like checking the available bandwidth, or like increasing audio quality only if this sound plays for more than 10 or 15 seconds, so it's no longer, so it's unlikely to be a system sound?
Currently, we don't do that, but it's possible. But really, Opus does it automatically. It's a variable bitrate codec, so it adjusts quality automatically depending on what's going on. Like if there's silence and all you hear is the occasional ding, well, it's not going. It's pretty much going to encode the silence as nothing at all. So, okay, right. So why take this approach? Well, first we need to provide and package Pulse Audio anyway for our client, because we support Windows and OS X, which don't run Pulse Audio anyway. So we've been packaging it all along. So, and this minimizes the number of components. We don't need to add anything extra. We're just adding additional functionality to a component we were using anyway. We think this also fits quite nicely into Pulse Audio, which already has networking functionality, so we're not doing anything all that weird either. And Pulse Audio provides a control protocol that can be used for adjustments and monitoring. And that's Pulse Audio has a protocol that can be used for loading modules, setting up networking, checking which devices are present, things like that. So we don't need to implement our own system for controlling the connection because Pulse Audio already gives us one. And we hope that we can get this accepted upstream, which will save us work in the future. But meanwhile, we still have it. Okay, so there is a patch. It was originally developed by somebody called Gavin Darkglider and was submitted to the freedesk.org bug tracker. But we've made improvements on top of that. We've ported it to the latest version of Pulse Audio and made some improvements on top of that. And there's been a slight